Last week we completed chapter 16. Now today we start chapter 17 chemistry grade 10. Plus I told you parallel to this I will be starting the grade 11 work also. That is grade 11 first lesson living tissues biology. Grade 11 first chapter living tissues. That means both plants and animal tissues. And this is the theory tutor. Actually last night I posted this to your WhatsApp. You might have not got a printout of this because since I posted this last night, therefore don't worry, I won't be discussing this completely. First I'll complete the grade 10 chapter 17. After that the last 30 minutes or half an hour, I'll discuss the grade 11 work. Okay, so grade 11 there are 15 lessons. Grade 11 science, there are two parts, so part 1 and part 2. There are 15 lessons in grade 11. So basically there are 15 lessons. So actually grade 11 most of the lessons physics and chemistry. And chemistry, biology the content is less for the grade 11. Therefore grade 11 is little harder than grade 10, but there are more practical applications than grade 10. Now the first chapter biology, and you have to complete unit 1 to 5 first term, then unit 6 to 10 second term, and unit 11 to 15 third term. So that is the term wise breakdown of the grade 11 syllabus. If you want you can copy down that grade 11. Look at the screen. I'll write on this screen. Grade 11 science, there are actually part 1 and part 2 textbook. Part 1 consists of grade unit 1 to 8. Look at the screen. Grade 11 science textbook. Grade 11 science. So if we take the unit 1, 2, 3, 4, 5, then unit 6, 7, 8, 9, 10, then unit 11, 12, 13, 14, 15, right? So out of this, look at the screen. So this is your first term. First term, second I'll classify this way also. You better copy down this in your, everyone should maintain grade 11. You can continue the same textbook that we have used for the grade 10 for this biology. Grade 11. Grade 11. Right. Grade 11 science. Grade 11 first term. So this first term unit 1 to 5. This is first term. Here the second term. And this is third term. But anyway, the government schools, they are going to start the grade 11 first term in 18th of April. Right, 18th of April. So we can start this first term government and semi-government schools. Government and government approved private schools. All those schools, the 18th of April. 18th April 2022. That means after the New Year holidays, they are going to start the first term grade 11. But private schools, they have already started, I think most of the private schools, grade 11, because they start the term in September, most of the schools. But anyway, I won't wait until April. I told you within this month, so parallel to the grade 10 last few lessons, I will be starting the grade 11 work. Now you should better copy down this in separately in your writing book or CR book, grade 11 first term. Where some students, they don't know, because textbook it won't say up to which term you are getting, up to which lesson you are getting the first term test. So therefore first term test you are getting until unit 5. First term test you are getting until unit 5. Actually unit 1 is bio, right? Unit 2 that also bio, and unit 3 chemistry. You better copy down this term wise breakdown of grade 11 science syllabus. Unit 4 physics, unit 5 also physics. So this is grade 11, and grade 11 second term, grade 11 second term, unit 6 bio, unit 7 chemistry, unit 8 chemistry, unit 9 physics, unit 10 physics. And grade 11 third term, grade 11 third term, unit 11 electronics physics, unit 12 unit 12 chemistry, unit 13 physics, unit 14 chemistry, and unit 15 biology, biosphere. So this is grade 11 term wise breakdown of the syllabus. Now you can see second term only 3 out of these, only biology lessons, only this out of 15 lessons, only 4 biology lessons, everything else chemistry and physics, all the others chemistry and physics. Actually, especially when it comes to the third term, the hardest lessons you are getting, unit 11, this 11th lesson is electronics. So the hardest lessons under physics, electronics. Then unit 12 electrochemistry, all and then 13th electromagnetism, all electromagnetism. And if you count this unit 10 electricity, domestic electric circuit, again electricity. So you get here the unit 10, 11, 12, 13. So electronics, electrochemistry, electromagnetism, electricity, like that. So therefore these are the hardest lessons in the grade 11 work, the third term and second term. So this is the heat lesson, heat. So you are getting essay type question from these few lessons, mostly essay type question. So this is the system lesson, biology. All the systems you are learning about 6 systems here. 6 systems means like digestive systems, respiratory system, blood circulatory system, right? Like that, excretory system, nervous system, endocrine system, like that. Around 6 systems. And the other system you have done in grade 10, reproductive system. Right? So this is the term wise breakdown of the grade 11 syllabus. So you better copy down this separately in your writing book. Please copy down this separately in your writing book, and because it will be useful, because the textbook they have not given this term wise breakdown of the syllabus, they have not given in the textbook, that's why, right? Okay, so now erase, quickly copy down this. Then no need to ask from anyone. Third term test, grade 11 first term test, up to which lesson we are getting. Some students, they have that doubt. Sometimes the teachers also, they don't give a proper answer. Then the grade 11 second term, up to which lesson you are getting the questions. Then grade 11, actually grade 11 first term test, you are getting grade 10 everything. Grade 11 first term test means grade 10 everything, and grade 11 up to chapter 5. That means 25 lessons altogether. Grade 10, 20, and grade 11 first 5 lessons. That is your grade 11 first term test. And remember your grade 10 third term test. Grade 10 third term test. I am talking about these government schools and government approved the private schools. Grade 10 third term test you will be getting, right? Grade 10 third term test. That means Western prize paper. Western prize paper. Western prize paper. Some of the private schools you might have already done this and you are promoted to grade 11, but still what? All the government and semi-government government schools that the students are still in grade 10. They will be promoted to grade 11 on, I put here, they are here 18th of April. The vacation after the term test, after the grade 10 third term test, they will be promoted to the upper grade, the next grade, right? Therefore, this will be mostly 23rd of March, end of March, between 23rd of March 2022 till 1st of April 2022. So within this period you will be getting the Western prize grade 10 third term test, right? And after that, after then 8th of April, they are giving the school holidays. 8th of April to 17th, then the school holidays. After 18th again, 18th they will start this again, the new term. That means new term, first term for the grade 11. First term grade 11, 18th of April. Quickly copy down this grade 11's term wise breakdown of the syllabus. Please raise the hand those who copy down this. Anyone of you else to copy down this? So you write this in the grade 11, under like I mean the same biology, or if you have a new textbook, sorry, writing book, you write the grade 11 science, grade 11 science content. Okay. When you're done, please lower your hand. This is from 20, not 23rd. Actually, this is 25th. This is 25th. Sorry. 25th of March. Okay, I'll erase the screen now. Let's move to the lesson now. Sumela, you are done, or you have a question to ask?
No, sir, I have wrote that.
Okay. Okay. So then we'll I'll erase this and I will start this grade 11 and grade 10 parallel to this. First I'll move on to the grade the living tissues I have given. Right. You can see the screen now. First I'll do the grade 10 17th lesson, and after that I'll discuss the living tissues grade 11, right? Okay, first we'll complete the grade 10 first half. Now grade 10, this chapter 17 rate of reactions. Rate means how fast something is happening. How fast you are eating, the rate of eating. How fast you are running, rate of running. Rate means how fast something is happening. Whether something happened fast or slow, we use one measurement, or the parameter, we use time for this. If you take like long time for something, so your rate is low, your rate of writing. So you take more time to write the same content than the other student, then means your rate of writing is low, very slow. Your rate of writing fast, how fast you are writing, that means time matters for this. Less time, fast. This to do the same work, if you take less time, you are fast. Less time. If you take less time to do something, that is fast. If you take more time to do something, that is slow. That means it's relative to time. No? Relative to time, we express the fast or slow. So time is one of the main factor here, whether something happened. Therefore, rate means how fast something is happening. If it is a reaction, rate of reaction, how fast the reaction is going on. What is the benefit of rate of reaction in our day-to-day life? Okay, if you can, okay, imagine, I'll give one example. These days, we are facing a problem. Raw material now we don't have. Say example, tile, ceramics. Most of the productions now it's we can't supply the demand. Gas or maybe agricultural product, rice or LP gas or cement or whatever. Okay, cement industry. There's a shortage of cement in the market sometimes. Now it's a chemical product. Cement will be a chemical industry. LP gas, chemical industry. If you take most of the others, like chemical industry. This is a chemical industry, cement industry. So this cement industry, chemical industry, if the reactions taking place in the cement industry low, there are many reactions taking place even in the iron extraction, blast furnace. You have learned in this chapter. Cement industry is not there in your syllabus, but anyway, it's a chemical industry. You need various raw material. Now in this chemical industry, production of cement, if that is happening fast, then you can supply the demand. Right? When you increase the rate of the production of cement, that means you get more products in less time. You get more products in less time. More products in less time. So is that useful? Yes, very useful. More products in less time. What is the benefit? You can supply the demand, plus you can reduce the time taken for the process. If you increase the rate or how fast cement production take place or the reactions, then actually to get the product fast, you have to increase the reaction. To get the product fast, the reaction should speed up in the chemical industry. If I write, I'm not directly going for the subject content now. I'm telling the importance of learning this lesson. Importance of learning this lesson to our day-to-day life. What is the outcome of this lesson? For what we are doing this? Right? To get the product fast, what should happen? Chemical reaction should speed up. Chemical reactions should speed up. Then we have to make changes, because same reaction we can't change. The same reaction, but we have to speed up that. That means same person, we have to boost energy. We give some energy drink, right? Energy drink, or we give him some glucose, or before the marathon, then he is running fast. He put some glucose to his mouth before the marathon or before the 100 meters race. Sometimes some of the people, they take illegal drugs also. And if they get caught, they lose the medal also in Olympics. So why do they take such illegal drugs, or maybe steroids, or various methods to the metabolic activities taking place fast in their body? Then they can run fast. Same thing we are doing here in a chemical industry. If you make the reactions to happen fast, you can get the product fast. So many benefits. Running cost reduce, electricity bill reduce, labor cost reduce. Otherwise, just to do the same thing, it will take 3 days. 3 days one, you are doing it, finishing in within 1 day. 3 days work, you finish within 1 day, you get the same quantity. What is the benefit? 2 days, the electricity bill reduce. Extra 2 days, labor cost reduce. Extra 2 days, the running the machines, they are worn out. When you are operating the machines for 3 days, they are getting worn out. I mean, gevilayana. So you can reduce that. And you can, not only that, you can supply the demand. Otherwise, what happens? There will be a shortage of that product in the market. Or else you lose the customer. You lose the customer. Now these days, if you order tile in Sri Lanka, because now they have stopped importing tiles from China. So if you go to this top, the brands like Rosel, Lanka tile, then if you order, I think you have to wait about 6-7 months. That all, you have to pay also advance about 50%, and you have to wait nearly 6 months, right? So that means what? They can't supply the demand. They can't supply the demand because raw materials come from the other countries. We don't have dollars to import raw materials now, enough raw materials. These are the issues. Because some of the chemical industries we don't have in our country. We have the soap production, but caustic soda, sodium hydroxide, we are importing. So therefore try to understand. I'm not directly not going, I mean giving the theory note. I'm telling understanding, learning, benefits of learning this lesson, right? So then who knows how to speed up the reaction? Who can do this? Reaction should speed up, right? To get the product fast. Chemist. Those who are specialized in chemistry. Chemist. Rasayana Vidyajna. He is the person who is handling this. So he will change the temperature, various things to speed up the reaction. They will modify the conditions. Conditions should be changed. So maybe the temperature. Then raw materials, the nature of raw materials. Raw materials, whether it's added in the large pieces or powdered form. Physical nature of raw material. Physical nature of raw materials. Physical nature of raw materials can be modified to speed up the reaction. Right? Not only that. Now, example, digestion of food or even in your body, some reactions can occur fast. I'll give some examples. So, temperature modification or physical nature of reactants. That means you add the say limestone and gypsum and those raw materials for the production of cement. You add them in the powdered form. Or one of the best example for making the curry, you put curry powder. You don't put a cube, no? Turmeric cube. Kaha, like, kind of cube. We put powder. Chili powder. We don't put large, pieces. So therefore, why do we add them in the powdered form? Salt, not a large piece or crystal. So we put powdered salt. Right? Why? They dissolve fast. Powdered form, it's diffuse everywhere in the curry, and then it takes less time, right, to get the effect. Otherwise, that means nature of the raw material matters for this. In addition, that there are some modified, catalyst. We will discuss in all this. By using various these, by modifying the same reaction, same products, same byproducts, but you change the condition, reaction condition you change to get the product fast. That means you are increasing the rate of reaction. Therefore, rate of reaction for you to get marks in the exam, but rate of reaction when you go to the industry, it's very, very useful. Continuously they are doing research for these reactions. Okay, example, production of paracetamol or maybe pharmaceutical products, medicines or vaccine. How fast the vaccine is produced. So all this chemical process. Otherwise you can't supply the demand. People have to wait for a longer period to get the vaccine. Therefore, rate of reaction is in A-level chemistry and beyond, university level, we call it kinetics. We don't use the term rate of reaction. The same lesson, this rate of reaction there in the A-level chemistry. Rate of the reaction you learn in university level chemistry also, and beyond that also. We call it chemical kinetics. Kinetics. That is the advanced term we use for the rate of reaction. Chemical kinetics. Right. That is the 11th lesson in the current syllabus of the A-level chemistry syllabus. Current A-level chemistry syllabus, chemical kinetics. Right. Now, I gave the introduction to the lesson. What is the importance of rate of reaction? how fast something, rate means how fast something is happening. So in this lesson we are discussing there can be physical changes also, no? How fast something happening, some in certain cases we have to slow down reaction. In some cases we have to reduce the rate. In some cases we have to increase the rate. Example, cancer. So cancer, how fast the cancer cells are forming, that is, if that happen fast, then you are in trouble. You will die soon. That one we have to reduce. There are certain cases we have to reduce. So example, fire. The fire we should reduce the rate, right? Otherwise you will get more damage. Therefore, fire combustion reaction is combustion also a reaction. Combustion also a reaction. Combustion reaction we have to slow down. Then we have to reduce the temperature. We have to cool it. We have to cool. That's why we put fire extinguishers, water, different cool in the system, right? So in some cases now in chemical industry, if you are going to make a product, then the increasing the rate or speeding up the reaction is good. But if it is not useful product, or if we want to reduce it, that means there are instances we have to reduce the rate. Most of the cases we are increasing the rate, but there are some instances we have to reduce the rate also. For that means we should be able to control actually. Right. Okay. Sorry about that. There's a sudden power failure. Okay, I connected again. I'll share the screen. Okay. You can see the screen again. Right. Okay. You can see the screen again, right? Okay. I connected through the right devices. The router is not working because when there's a power cut, right? Now, randomly, like, they don't like without, sometimes you also might experience this when you're doing online. So suddenly there can be like nearly 1.5 hours, there's a power cut again from, I think, from yesterday also that happened. Therefore, anyway, you have to keep your device ready, fully charged. So I keep always my device fully charged, as well as if when the router is not working due to power failure, then I have a alternative method also. Therefore, you also should be well prepared. It is not an excuse, power cut, therefore can't join the class. It is not an excuse. You should be well prepared. You have to be proactive than reactive, right? Now, I told you fast reactions. Look at the screen. Some reactions occur very fast, some reactions occur slowly, and I told you the benefit of both. So slow reaction also sometimes can be beneficial if you don't want to make this happen fast. Now, in our day-to-day life, can you suggest some they have given this in the textbook also. Even you can propose any other good example rather than the ones given in the textbook. I told you the importance of this increase in the rate of reaction in our day-to-day life. Okay, look at the screen. First one, we can write few examples for the fast reaction. That means actually some reactions can occur within 1 second. Some reactions can occur within few minutes. Some reactions can take place within few. It can occur for few hours. Some reactions can occur for few days. Some reactions can occur even several months or even several years. I'll give one example. Some nuclear reactions, nuclear reaction, so that can happen. Depend on the half life. That can happen very fast or very slowly. Right? So therefore, fast reactions. Or you have. I'll give a few examples from your syllabus. If you put a piece of sodium into water, reaction of sodium with water, it's very fast within few seconds. So I have shown you the video clips also. When you put a piece of sodium or potassium into water, it happens very fast. So that is a relatively fast reaction. But this is relative, yeah. You can't tell like I mean based on some of them you can't directly tell. Right. Okay. First one, right? Reaction of sodium with water. Write the first one under that. Reaction of sodium, that happened very fast. But if you put an iron nail or a coin into water, that won't happen very fast. Reaction of sodium in a group 1 metal, not only sodium, any group 1 metal with water very fast. With water. If you take a reaction of say magnesium with dilute acids, reaction of magnesium, reaction of magnesium with dilute acids, so dilute HCl, with dilute HCl or dilute acid, that is fast. Not only that, ignition of petrol or LP gas, ignition of, now you can see the gas because suddenly the blast like a bomb in the kitchen, LP gas cylinder, LPG gets catch fire. So there you can write ignition of petrol, blasting of a cracker, ignition of petrol. That's why fuel filling station, that's dangerous. It's danger. Even no one should light up cigarettes or lighter or matchstick. So you should not use. Even they advise the drivers to keep the engine pumping petrol or the fuel into the tank to even because when you start the of vapor in your vehicle, so during that experience in the highway, some vehicle literally burn because highway, like due to the friction and air resistance, or when you are running the engine long hours, I mean high speed, so it's get heated up and it's daytime, and due to various injectors and all, due to various defects, so there can be petrol vapor can accumulate in certain parts of your vehicle, then it can cause fire. So ignition. The other thing is, so after collision of a vehicle, there sometimes what happens, there can be a leak of petrol or diesel from the fuel tank, and then also it can cause fire, right? Ignition of petrol or LP gas, petrol, diesel, LP gas, or even if you go to hardware, ignition of this what is this called, you can say LPG, and in addition to that is thinner turpentine also getting catch fire easily. The hydrocarbon, turpentine, right? So etc. These are getting catch fire instant. In addition to that, if you can add one more example, blasting of cracker. blasting of a cracker. It's a fast reaction. It happens within few minutes sometimes, I mean, like maybe few seconds. So these are fast reactions or rapid reactions in our day-to-day life. But on the other hand, slow reactions. So let's see some relatively slow. With compared to these reactions, they are slow. Otherwise, I mean, there's no like margin like okay, uh, they have not given in the textbook the reactions that occurs within uh, less than 2 minutes fast. So you can't put like less than. Sometimes you can put a criteria for this, but they have not given a criteria relatively. That's why we use the relatively, roughly. Okay, now let's see the slow reactions. Now, what are the slow reactions in our day-to-day life? So, example, ripening of fruits is a chemical process. Ripening of fruits, it takes some time. That what natural ripening. Sometimes the people they put various carbide and various chemicals for increasing the ripening artificial plant hormones to increase the ripening of fruits. Those who are selling fruits, but that is artificially. Naturally, ripening is a slow process. It takes some time, maybe few days sometimes. It won't happen within 1 hour, right? It will take more than 1 day. Ripening of fruits. That is slow. That is slow. In addition to that, digestion of food. Digestion of food. That is also a bit slow process. Why? It takes few hours. After eating your breakfast, you can stay nearly 4 to 6 hours. It takes several hours. Digestion of food slow reaction. Digestion of food. Then in addition to that you can write if you take rusting of iron, right? Iron get corroded. Iron nail, if you keep an iron nail, the rusting of iron nail. Rusting of iron, it takes sometimes several months. It will take several months for the rusting of iron. Yeah, Sumela, you have a question to ask?
Sir, action of enzymes in during biochemical reaction is a fast reaction or slow reaction?
It's bit slow. Sumela, digestion of food, that is by enzymes. Ne? That is by enzyme. But the thing is this: if they are, because the food that you eat large pieces, ne? Digestion of food, chemical digestion, you are chewing them inside the mouth and then broken down into small pieces, then it only in the stomach it takes nearly 3 times some time. So in the small intestine used to increase the one enzymes. Enzymes are biochemical nutrients to into our body. We give soup. We don't give hard. I mean to digest. That's why we give babies or infants either mother's milk or only the breast milk, or they will give like like semi-solid. Earlier like only like liquids type food, and then semi-solid, like gradually it increase because they don't have teeth to bite them into small like to break down into small pieces, the infants or the babies. Therefore it's difficult to digest. Mechanical digestion is very difficult because since they don't have any teeth until about 1 or 2 years. And then the next one is their digestive system is not fully functioning, like kind of it takes some time for, right? Therefore we don't give solid food, heavy meal to those babies. We give porridge or something like that, soup or something, right? Therefore it's very important uh, to understand, or else in the exam if they give a list like this, you should know how to select the fast and slow reactions like this, right? You can have many examples, not only this, you can write many examples. Shall I erase this? Anyone still copying down? Fast reactions and slow reactions. Now Next one, most important thing, I told this last night, the grade 11 batch also, if possible, you better use your what is called grade 10 teachers guide. If you look at the learning outcomes under this grade 10 teachers guide TG for the new syllabus, grade 10 TG, look at the screen, grade 10 TG. This is the teachers guide. You should have at least grade 10 and 11 teachers guide, because it's very very important. Then only you know whether teachers are teaching the right thing or not, right? You can have that as a reference. You can have that as a reference. So example, I'll give one example. You can see the grade 10 chemistry part. You can see this. This is the grade 10, this section, this lesson, the TG. Shall I read this? Can you all see here? Learning outcomes. Learning outcomes. Here. This is unit 17 TG. Unit 17 TG. Teacher's guide or teacher's instruction manual. Rate of reaction. Give examples from day-to-day life relatively fast and relative. So that means the student should be able to. That means you should be able to do this. This is what they can test in the oral paper. Remember, the paper is set based on this teacher's guide, number of periods allocated, and this is the competency and competency level. Learning outcomes, we call it Iganum Phala. After learning this lesson, the student should be able to define the rate of reaction. That is what I am going to discuss next. So remember, from these areas you are getting questions in the oral paper. Right? Remember, not some teachers teach only from the textbook. That is also dangerous, because some essential parts can be missed. Now here the factors affecting the rate. So you controlling the rate. So therefore I explain how factors affect the rate. Like that, this is what they at the end of this lesson they can test these areas by putting questions. Therefore, you can have that as a cross refer, but anyway, no need to worry about instruction for the lesson plan. Therefore, that is for the teacher. But anyway, they have given the keyword, concept, and all, right? Controlling rate of factors affecting the rate of reactions are controlled to get desired results. So you should be able to control the rate, right? Okay, let's move back to the theory again. Did you all finish copying down this? Anyone? I see some students joined very late today. Anyone still copying down this? Please raise the hand. Shall I erase this and move to the next part? Okay. I'll erase. The next one, let's see the definition of rate of chemical reactions. Rate of reaction definition is this: amount of change in a unit time. Change means in a chemical reaction there are two things. Reactants getting used up, products are forming. Reactants are used up, products form. How fast products form? That is a change. How fast reactants are used up? You can look at the reactants and tell the rate, or you can look at the products and tell the rate. Both we can use. How fast reactants are used up. That means if the reactants are getting disappeared fast, I'll give one example. You put piece of magnesium into water, or you put piece of, okay, not magnesium, say imagine you put piece of sodium into water. Sodium. So after some time what happened? The sodium, it disappeared. Sodium is the reactant. It react with water. Sodium and water reactants. So you get the product what? Then what happened? The sodium, it's decrease in size. It decrease in size. The large sodium decrease in size. And what is the gas given out? Hydrogen gas is given out as a product. And sodium hydroxide will be formed here. Those are the two products, sodium hydroxide and hydrogen. Then no more sodium after that. So the sodium, it decrease in size. Sodium getting disappeared. Used up. Sodium utilized. So you can look at that sodium, how fast this decrease in size. Then you can have an idea whether it's going to react with water fast or slowly. If the sodium, it remains the size of the sodium, the piece or the whatever, it's melted into a ball because of the exothermic reaction. When you put a piece of sodium into water, it will melt into a ball, but with time it decreases in size because it's getting used up. It is an indication how if this is getting disappeared fast, sodium, that means the reaction is rapid. Reaction occurs very fast, rapidly. But if it is happening very slowly, if the sodium piece remain longer period in water, that means what? The reaction, that means you can look at the reactants and tell the rate. How fast? Or else you can look at how fast this hydrogen is coming out. How fast the hydrogen and sodium hydroxide is, that is called how fast the products form. So in a unit time, right? Or else you can check the mass. You can take the sodium, say you add 5 grams, and you after 1 minute, unit time is in after 1 minute per minute. In 1 minute you check how many grams left. But actually it will not be left after 1 minute, it will get disappeared. But if you put some other metal, it will retain, right? If you put a large piece after 5 seconds, you can check unit time. Then in 1 second, how many grams? Look at here. After 5 seconds, you check the sodium piece back and you put the weight. Check the weight. Check the weight here. Then you get what? Only when you check the weight, 5 grams initial, but finally what happened? Only 2 grams left. Say only 3 grams left. What is the amount utilized? 5 minus 3. You add 5, then only 3 grams left. The reactant. That means 2 grams used up. 2 grams utilized in 5 seconds. In 5 seconds. Then you divide 2 grams divided by 5 seconds. You get what? 0.4 grams per second. That means 0.4 grams getting used up per second. That is called the rate. That is called rate. How fast the reactant? That means per second 4 grams. 2 divided by 5 is 0.4, right? Yeah. So 0.4 grams of sodium getting used up per second. That is called the rate. So you put the reactant. After some time you check the weight again and find how many grams lost. So 2 grams lost now. 5 will become 3 grams means 2 grams lost. In how many seconds? In 5 seconds. Therefore within 1 second 0.4. How to find? 2 grams divided by 5. Time. This means you divide this by time. Reactants used up divided by time taken. What is the how many grams of sodium used up here? 2 grams used up. Look at the, try to understand. No point of memorizing this equation. You will not improve, right? So you get the concept using this example. So you add 5 grams. After 5 seconds, this much only left. So after 5 seconds, after 5 seconds, only 3 grams of sodium will be left. You can check that using the electronic balance. Electronic balance, not a normal balance. Pan balance also not going well. Then you time taken 5 seconds. Reactants used up 2 grams. Then what is the rate? 2 grams per second. Sorry, 0.4. 2 divided by 5 will be 0.4. This is how you find the rate. Amount of sodium reactant is sodium. 2 grams used up. Time taken for that 5 seconds. So this is how you measure the, otherwise I can just complete the blanks and tell measuring the time taken for the utilization of you memorize, but no point of memorizing anything or any definition without understanding how it happens. So did you all get it now? How to measure the rate? You can use anything else. You can use anything else. You put magnesium or you can put any other reactant and check how fast it's getting disappeared, how fast it is getting used up. Then you can, if it is a mass, you can take the weight. If it is concentration, you can find the concentration, change of concentration, change of mass, right? You can, so therefore reactants utilize. Or else you can take the product form also. You can, okay, first we'll complete the blank for this. Okay, complete the first blank. Measuring the time taken. Now do you understand what does this mean? Measuring the time taken. Time taken you have to measure. What is recorded here? Time taken. You record immediately after adding this piece of sodium into water, you start the stopwatch. And immediately you take this out. But actually practically it's very difficult to handle this. But anyway, if you write something like magnesium, that will be easy because magnesium is reacting very slowly with water. Say you put hot water and you can, or you can put calcium or something. Or else you put say example iron nail. Iron nail it has got rusted, then you remove the rust and check the clean iron nail again the weight, then you can tell decide how many grams of rust form from the iron nail, like that. So different methods you can use for this. You can check the weight. Sometimes you use calcium carbonate. You put calcium carbonate and HCl. Calcium carbonate reacted with HCl, then carbon dioxide is coming out. Then you can check the calcium carbonate, you put a piece. So after maybe 5 seconds you take the calcium carbonate again and check the weight, something like that. So these are given, I'm giving examples, but they can give any example like this in the exam. They can give any example like this. If it is a mass, you can check the weight, loss of weight. Or else you can do like this also. Look at the screen. Now you can do the reaction on the balance. You can do the reaction on the balance. You can put the beaker here and you can check the digital recording. You get here the digital record. So when the reaction is getting used up, what happened? Carbon dioxide gas is given out, then the reading goes down. So this is like university level, they do like this, right? Online monitoring, right? Online, like, you know, not remotely, online, like means at the same time you monitor the loss of mass. When the mass is lost, what happened? This will decrease. It will indicate in the digital balance, like that. Then no need to take it out and you know, get the wipe it with a clean piece of cloth, and then again get the dry weight. Like it takes some time. So but here it's digitally you can monitor that. If you are carrying out the reaction on the balance, you put the beaker on the balance and check how many grams is going out, right? So that way also you can do it. So example, you put calcium carbonate you add, and then you check the loss of mass. Okay, but anyway you will learn this in detail in G11 chemistry also under chemical kinetics. So but anyway you got the idea, and time taken you record, and the other one loss of given amount of reactant. It can be loss of mass, right? Loss of mass. Say example, 5 grams of sodium become 2 grams of sodium after 5 seconds. Then you check loss of mass 5 minus 2, then 3 grams loss, and time taken for that. So what are the two measurements here? Time taken you have to record, and the loss of mass or the loss of the concentration or whatever in the reactant you have to monitor. So come to the blank, measuring the time taken. Actually I have given already this, no, measuring the time taken. Okay, anyway I will write it, measuring the time taken. I think I have given already and I have again put the blanks. Anyway, it's okay. Measuring time taken for the loss of given amount of products. So that means actually I wanted to highlight this, the time you have to measure and the loss of mass or the whatever the concentration you have to monitor, you have to record. Then only you can add those two values here. The loss you put here and time you put here and get the rate. So then what are the units we use for the rate? So we can have, there's no definite unit for the rate. Now sometimes SI unit we put always in seconds or something, but there's no rule like that. Okay. I will you can mark with a pencil like that. The loss will be the numerator and denominator will be the time taken. Right? Try to understand the concept. Otherwise, I don't need to explain this much. Try to understand the concept. If you get the concept to your head, then it's that rate of reaction will be very easy. You know exactly what is happening. Otherwise, you are just like a clerk. You are just like a parrot, you are just memorizing the text in the textbook. Memorizing text anyone can do and repeat it. Even a person without scientific knowledge also can memorize these things and can repeat again in the exam like a bookworm. That is not the aim of this. Remember that. Now unit of rate of reaction. Okay, how can you measure the unit? Now I told here grams per second, or sometimes you can write grams per minute. You can use different units. We will write some few example units of rate of reaction. Please write moles per cubic decimeter. Concentration we write moles per cubic decimeter per second. Moles per cubic decimeter per second. Moles per cubic decimeter means concentration. Per second means time taken. This is the most widely used unit, but if you want, you can write even within bracket grams per second also can be accepted. Grams per second or grams per minute. Grams per minute. It depends on the there's no definite one. It depends. So it can be milligrams per second. Loss of the mass of sodium in grams per minute. If it is very slow, we can tell in minutes. If it is very fast, we can tell this in seconds. If it is very slow, sometimes it will take few hours. Then divide by number of hours, like that. Sometimes you can see the lorry bus, they put kilometers per hour, the speed limit, kilometers per hour, like that. Sometimes you can tell the volume. You can tell the volume also. The release of, say, you can tell milliliters per minute, milliliters per second. Or you can tell sometimes milliliter means cubic centimeter. Cubic centimeter, how many milliliters of getting used up? If it is a gas, we will measure the volume. No, we can't tell the mass. Ne? Cubic centimeters per second or cubic centimeters per minute. Maybe hydrogen or carbon dioxide gas, you measure the utilization of the gas during the reaction. It depends on the rate, how fast it's happening. The time can be in minutes or hours or seconds. Some reactions occurs in seconds, so we will use grams per second or cubic centimeters per second. Some reactions occurs in few minutes, then we express that grams per minute. Some reactions may occur for few hours, then we can kilograms per hour even, no problem. If you are putting that in large scale, you can express that in different units, right? Then next one you can measure the product. So the time, measuring the time taken for the formation of given amount of product. So next blank, right? Measuring the time taken. Even 100 meters race, Olympics, they record the time, right? Time will be the factor. How fast they are running. What is recorded? Time they tell, okay, this one complete 100 meters race in within 9 seconds, the other one 9.5 seconds, like that. So then you can find you can easily find the fastest runner. What is the product here? 100 meters. You keep the distance fixed 100 meters and you record the time taken by each person participate in that event. You check the time, you record. The same thing here. We keep the product for the formation of given amount of products. Say they are 100 meters. Our target is 100 meters, but time will change depend on the runner. Here also our target will be same quantity, maybe 1 gram or maybe 1 milliliter or maybe 5 milliliters. So we give the fixed given amount of products, formation of given amount of products. So come to the blank for the formation or for the production of given amount of products. For the formation of given amount of products. Time taken for the formation of given amount of products. Loss of given amount of reactants. Example, loss of 3 grams. What is the time taken? So therefore, by looking at the reactant also, you can look at here pink. By looking at the reactant also, you can tell the rate, as well as by looking at the products also, you can decide the rate. Time taken for the formation of given amount of, I'll use that the same, I use blue for the products. Products from here I put blue. Therefore, here also I use the same color for the time taken for the formation of given amount of products. Right. In the exam, if you can't remember this, at least if you write the equation also, they will consider. Right? They will consider. They will give marks. Rate of reaction equal what? Time, amount of reactants utilized over time taken. Or else the other method, amount of products formed. Look at the screen. Amount of products formed, that under B at the bottom. Amount of products formed over time taken. Amount of products formed over time taken. So they are also unit. You can tell the same thing. 5 milliliters of hydrogen, what is the time taken? You can have the several reactions giving the same product. So example, I'll give one example. You take HCl and add magnesium. Then you take HCl and add calcium. You take HCl and add, say, iron. You take HCl and add, aluminium. Now you want to in each, okay, how many reactions now going here? 1, 2, 3, 4. Each reaction, the product will be same. In each reaction, product will be same. You get hydrogen gas. What is the product coming out? Hydrogen gas. Product will be hydrogen here. Hydrogen will come out. In all this, hydrogen will come out as a product. When metal react with acid, hydrogen will come out as product. So you record the formation of 5 milliliters of hydrogen. What is the time taken? To get 5 milliliters of hydrogen, first reaction, imagine, I'm giving some, this is how you get questions in the exam. Otherwise, they don't ask what is known as rate of reaction. What are the units of, you don't get such questions under new syllabus. They will give a table or data like this. 5 milliliters of hydrogen in each reaction, what is the time taken? See the practical applications of this experimental design. Now the first reaction, who can guess which one will take less time to get the same quantity of hydrogen? Yes? Please raise the hand. Now magnesium, HCl. Okay, I'm asking simple question. Magnesium is added to HCl. HCl, same quantity, same condition, same temperature, same concentration. Other conditions should be same. Other conditions should be same. Magnesium with HCl, calcium with HCl, iron with HCl, aluminum with HCl. So I want to find in which one the reaction occurs fast, or in which one hydrogen 5 milliliters given in less time. So that's what we are discussing now. This is how you get the question in the exam. Then they'll ask which reaction is fastest. How did you measure? What are the measurements in this reaction? What condition should be kept constant in this reaction? Okay, I'll ask the answer from which one you guess will give same quantity of hydrogen in minimum less time? Who will be the fastest out of these? Calcium with HCl, iron with HCl, aluminum with HCl, magnesium with HCl. Fastest one, Suran?
Calcium.
Yeah, very good. Calcium will react fast with HCl. How do you know? How do you know? How did you get? Yeah, Suran is there. Can anyone guess? How do we know whether calcium react? Because without, now theoretically you tell, without doing the experiment, now you are giving me the answer. Actually, if you don't know this, you have to do the experiment in the lab and get the data. You have to take the time. Okay, I put T1, T2, T3 like that. You have to record the time. Otherwise, how can you tell? It's like magic. But now you told the answer because you know chemistry. That is the role of chemistry. You know who is the fastest. I would type T1, T2, T3 the time. I didn't put the exact value. I put T4. So now Suran told calcium will react fast. Then you get the 5 milliliters of hydrogen less time. That is T2. T2 will be the lowest value, less time. That is the fastest one. How do you know? Yes, Suran, how did you know this answer?
It is situated higher in the metal reactivity series.
Very good, Suran. Correct. So how did you decide activity series? Activity series, calcium is above all these. Calcium is above all these metals. Therefore, calcium react fast with HCl. If I ask the second fastest one, or in which one the time taken is second lowest time for the calcium. This is the fastest one. Time taken lowest to get the hydrogen gas. The second fastest or time taken lowest. Second one, the time taken lowest. Yes, can anyone guess? Herath?
Magnesium.
Magnesium, obviously. Magnesium is the second fastest reaction here. Therefore, if you are going to make the product hydrogen in less time, then you can decide which reaction is better. If you are going to make a sample of hydrogen gas in the laboratory in minimum time, then you can decide, you can use your chemistry knowledge. Otherwise, what happens? Trial and error. You put that metal and this metal and it will take long time to find the fastest reaction. But scientists, they have done it. They have given the organized, chemistry knowledge. You are just studying them. For about last 200, 300 years, chemistry, the subject chemistry or physics or biology, that knowledge is well organized. Right? Well organized. It's like there's a format. So you are studying that 300 years chemistry knowledge. After a lot of research and reactions, you gather within 1 year. Grade 10. Within 2 years. So when you go to university level, maybe within 10 years, you gather the knowledge of chemistry in last 300, 400 years, the knowledge, the gathered. And you are, after that, you are repeating that in the exam and get a qualification degree. Actually, you didn't find anything new. Now also, you are not searching anything new. You are not research. You are not doing. But you are just memorizing what they have done, repeating that in the exam and getting marks. And you are telling me, I know chemistry. But the main objective, you should go beyond that. You should find something new and you should contribute to that subject. Then your name also will appear under the subject chemistry in the future. The students will learn your name also. That you introduce a law. Or you will find something new. This is the main objective of science education. We need the people, some innovative, products, right? Something very innovative, solution for an existing problem. That is the final objective. Otherwise, most of the people, they are memorizing or studying this and repeating that in the exam and getting, okay, I am good, I am bright, I am 98 marks. But you didn't remember, you didn't find anything new. The same thing what they have given, you are studying. For each reaction, you are not going to the lab and checking whether it's happening or not. We are not checking even because we are believe this, what they have given, right? Okay. Anyway, that is up to you to think beyond this. Now let's move on to the next part. So I gave a few examples how to decide the rate. Time matters, no? Okay. Fastest person, calcium with HCl, as Suran explained. So therefore, that is the fastest reaction. That means time taken we have to record. So therefore, in rate of reaction, we have to monitor the time for the formation of definite amount of products. Can you see here? Amount of product form. What is this? 5 ml, 5 ml, 5 ml. Given amount of products. What is that? Given amount will be 5 ml. What is the product? Hydrogen. Formation of 5 ml of hydrogen. Time taken changes. T1, T2, T3. Did you all get this now? What is the, otherwise you are just memorizing this. Measuring the time taken for the formation of given amount of product. You memorize this. And you are expecting the same thing in the exam. If that is not coming, you are telling paper is hard. No wonder. Remember that. Your main intention should be the improvement of chemistry knowledge. Then marks you automatically get. Right? Otherwise, what happens if you are thinking only about marks, then you can even copy the answers from the others because your final target is only marks. No, not the marks. Your final target, your main objective should be, you should be able to tell, I know chemistry well. I am good in chemistry. You should be able to tell that. Not the marks. Some students, they copy MCQ paper and they'll get good marks. But can we guarantee that that person is good in science, good in chemistry? Can't. Right? Okay. So you have to be honest. Right. Now I'll move to the next part. So you understood both this equation because most of the students, my past experience, they don't understand this equation or the expression as well as they don't understand the definition. They memorize the definition and write in the exam. They get marks, but they don't know actually what is happening. Now you understood actually what is happening. Industrially, this is very important. Speed in reducing the time. When you reduce the time taken for action, you can get more profit. If you reduce the time taken, labor cost reduce. OT time reduce, running cost reduce, electricity bill reduce, you can supply more products to the market. If you supply more products to the market, you can have more, I mean, you can get more money, you can get more profit. The sale increase. You will not lose the customers. You can satisfy the customers' demand. So that is commerce. But commerce or that business won't exist if there's nothing to sell. The products come from chemistry, chemical industries. Right. Remember, pharmaceutical product or any other product, even yogurt. Then I'll go down. Question number. Mention I explain this one unit. This also unit you can write. Cubic centimeter. Okay, if it is a gas, so you can write cubic centimeters or milliliters per second, or milliliters or cubic centimeter or milliliter. Actually, international standard. Actually, this is wrong. Mostly in Sri Lanka they put M simple L, milliliter, but actually it's wrong. It should be M capital L. You can check in any international book, even in the internet, milliliter they put ml, right? So therefore I'll write here ml per minute, milliliters per minute, or else you can write if it is a gas, milliliter or cubic centimeter. If it is if you get a solid product, right? If you get a solid product after reaction, you get a solid product. So can you all remember this brick red precipitate? Brick red precipitate, you got what? Benedict solution. Benedict solution react with monosaccharide and disaccharide and you get a brick red precipitate. So you can measure that precipitate, the mass. You can filter and get that, and you can check how fast that Benedict reagent react with the monosaccharide. That's why you are heating. Can you remember the Benedict solution? You are heating. Then you get the observation fast. Otherwise, you will have to wait long time to get the observation. Or else you can take grams per second or grams per minute or milligram. Even you can tell in milligrams. Depend. If it is a very tiny amount forming, we can't. If we can't express that in gram, we will tell that in milligram. Milligram. If you are getting a large amount, then you can express in kilograms per second. It depends on the nature of the reaction. The unit with the reaction, the units we are introducing might change. But best practice, what we put more concentration, actually moles per cubic decimeter per second. That is the best unit in A-level chemistry. They use this moles per cubic decimeter per second. Moles per cubic decimeter per second. Right. Therefore, this is actually this teaching not only targeting your school term test and oral exam. Remember. Okay, please raise the hand. How many of you are planning to do A-level science subjects? A-level science subject. Those who have already decided. Now you are this year you are in grade 11, then next year you are doing A-level, right? How many of you have already decided to do A-level science subjects? Now there are nearly 20 students. Very good. So then this knowledge will be very, very useful. You will perform better than the other students when you are doing science, A-level science. Right? Therefore this knowledge is very useful to you. Right? Okay. Let's move back. Next one, main factors that affect the rate of reaction. Otherwise I don't need to explain this much. That is the responsibility of the O-level teachers or grade 10, 11 teachers to give some extra knowledge also to the students for inspiring mind. You should have an inspiring mind, innovative mind, problem solving, critical thinking. Then only you will perform better in any subject. Right. Main factors that affect the rate of reaction. Okay. Now I'll give one example. Even in your body, when you get fever, right? When you get high fever, you are not eating very like a heavy meal. High fever you have. Will mother give like the fast junk food with lot of the other meat items and stuff? Right. Now high fever, you take soup or dengue. So you take porridge or soup or anything. You don't take pork, beef and all heavy meal, fried rice with you are not eating when you have high fever, because your enzyme action, when the temperature increases in your body, enzymes the activity is reduced. Then you can't digest the food that you eat easily. Right? It is difficult to digest food, and your body temperature can further increase. So therefore you have to take a light diet. Therefore, because when the temperature increases, whatever in some reactions can slow down, but on the other hand, in chemical in chemical reactions, when you increase the temperature, reaction occurs fast. Example, when you put piece of sodium into hot water, it's so dangerous than in putting in sodium. If you put into cold water and hot water, what? In which one it react fast? Sodium react fast, very fast. Even with cold water it react very rapidly. Sodium react with hot water faster than with cold water. Why? When the temperature increases, rate of reaction increase. With hot water you will get the product fast. Sodium will disappear fast with hot water. Therefore, that means one factor that will affect the rate is temperature. But on the other hand, in your body, enzymatic reaction, high temperature is not good. When you get high fever, high temperature is not good in enzymatic reaction, because enzymes are biochemical catalyst. Protein, they get denatured. Example, egg white. Egg white is a protein. When you boil the egg, what happens? It becomes semi-solid, like solidified. That means protein present in the egg white get denatured. Their structure changes, right? Albumin. So same thing here. Enzymes for some reactions will slow down at higher rate. Sometimes the products and the reactants can get destroyed. Therefore, increase in the rate. This also you have to be careful. You learn when the temperature increases, rate of reaction increase. Wherever you go, chemical industry, you become the chemist and tell increase the rate. Use the highest temperature forever. Use the highest temperature. You tell the laborers in the factory, you become the chemist, consultant for that industry. Okay, you tell use the highest temperature possible, because you have learned when the temperature increase, rate of reaction increase. Is that correct? You have to be very careful. It's very dangerous. What happened? Extreme temperature will destroy your product. If it is a pharmaceutical product, quality of the product you will lose the product quality. It will degrade. It will get decomposed. Reactants will get destroyed, get decomposed, broken down. Thermal decomposition can take place. Therefore, you have to check. Products can tolerate. This is the temperature that the product can tolerate without losing its quality. Then increasing the temperature, you can't tell any temperature you want. So you have to keep the quality of the product and the reactant, which they should be able to tolerate. Example, reaction chamber, it can melt because of high temperature. So therefore, temperature dangerous. You have from reaction to reaction, the temperature, the condition will change. Therefore, I can just tell temperature will affect the rate, but you can understand inside your body, fever, enzymes are not become very active. You don't get the optimum the effectiveness of the enzymes will decrease when you get high fever. That's why the parents are not they will not give very hard heavy meal when you have fever. So they are the opposite way. But in a chemical reaction, when the temperature increase, rate increase. But that also you have to be careful when increasing the temperature. I told in the other product, when you get high temperature, what is the other problem? You need fuel. You need to burn fuel. Sometimes what happens? Your fuel cost become more than the product, right? The price. Then what happens? There's a loss. Unnecessarily you are burning so much fuel to get the temperature. Then what happens? Because why are they giving a product? Because the main objective of the entrepreneur, so they are targeting the profit. So therefore, unnecessarily high quantity of fuel if you are using. Second problem, environmental pollution and energy cost. So therefore, you have to optimize all this. Now you can see, like, I can simply tell our temperature will increase the rate. But now your thinking ability is improving. Now, all temperature, very high temperature will affect to the quality of the products and the reactants. Very high temperature can cause environmental pollution when burning fuel. Very high temperature, production cost will increase. Environment, therefore, temperature, so many things to think, right? In a living system, high temperature will affect to the enzymes and the example. Some industries, microbiological industries, microorganisms are used to get some products, acetic acid, or in various industries, the microorganisms are used. What happens if you use high temperature? Microorganisms will get destroyed. Then no products at all. Therefore, telling the temperature easy, but different industrial to industry to industry, the way that effect will be different. I hope you understood the broad understanding about temperature, right? So write here the first one, temperature. Okay, now temperature. I'll write the first one, temperature. But you now learn a lot, because all what I explain, you can copy down if you want to separate it in your short notebook or somewhere. But keep those things in your head Then when you are doing higher study or A level or beyond that, that knowledge will be very useful. Temperature, right? Temperature will be one factor that will affect the chemical reactions, the rate of chemical reaction. Okay. Number two, all right, physical nature. That means I told you sometimes we are adding the things in the powdered form, right? Powdered form. Physical nature of reactants, or we call it surface area, right? The second factor, surface area. Okay. First, next one, surface area of reactant. What is the meaning of surface area? Okay, don't worry, we are going to discuss one by one in detail. Surface area, sometimes we call it physical nature of reactants. Physical nature of reactants. Now remember again this COVID, this Omicron. Because of Omicron, you will get Delta Cron also there. Now it's not, Delta Cron is more dangerous than Omicron. So after Omicron, you will get the Delta Cron, I think. Now it's again increasing the infected people gradually. So therefore, most of the schools, the students also infected. I'm not making you scared, but therefore, physical classes, I have to think twice again. By March, April, again, the condition can become worse. But anyway, they are giving the vaccine to the students also now. Let's see. I'll let you know by the most probably. I was planning to start the physical classes. Maharagama, Pitakote already started. Pitakote Nugegoda Monday class. 5:30 and 3:30 class, and the other places I have not started yet, right? Okay, but anyway, this online thing is permanent until your oral exam, right? No change of the time even. Now surface area. Surface area means you put a large piece of cube here. What happened? Into HCl. You put this into HCl. Look at the screen, everyone. So you put a large piece of say magnesium even. So what happened? HCl can interact with what? Only the surface first. HCl molecules come and collide with the surface only, can interact. Interior, the parts cannot interact with HCl. Right? So when you put HCl into HCl, you put a piece of magnesium or whatever, a reactant, maybe calcium carbonate. Calcium carbonate can react on the surface only, can interact with HCl molecule, and you will get the products only from the surface reaction. But if you are converting this into the same quantity, imagine you are putting here 5 grams of calcium carbonate, 5 grams of calcium carbonate with HCl, same 5 grams, so you put a piece here or a lump. Then this one, what happened? You are putting the same 5 grams in the powdered form. 5 grams of calcium carbonate in the powdered form. What happened? Now the powdered, same amount, powdered form. Now what happened? HCl can interact not with the surface one, interior one also now exposed to HCl. Calcium carbonate particles inside the lump or the solid also can, now there are more collisions. So interior ones also will come out because of after converting this into powdered form. Simultaneously, there will be more collisions, right? More contact of HCl with the interior particles also now freely available for the HCl to contact with. Interior ones also come in, but in the solid form, only the surface gradually is going in. HCl can, it takes long time for the HCl to contact with the interior particles. Now interior particles also exposed to HCl when it is converted into fine powdered form. Is that clear? Therefore, in chemical industry, they add the raw material in fine powdered form. One of the best example, iron extraction blast furnace. They put finely powdered form of these things, calcium carbonate, coke and hematite, Fe2O3. Then what happened? More contacts. There must be a contact. Without any contact, can reaction occur? No, they should come and contact. For any reaction to occur, the reactant should collide. They should come and contact with each other. If they are far apart, no reaction will take place. Therefore, it's easy for they can easily penetrate and go and contact. Now, example, one of the other example, the Pfizer vaccine and Moderna, they use lipid nanoparticles. Why nanoparticles? More surface area. Remember, you have done no grade 9, what is this called? Nanoparticles. Nanoparticles, when it become nano scale, what happened? Surface area, volume to surface area, that ratio increases. Therefore, more surface area, volume, surface area or volume, that ratio become very high when it come to the nano scale. Nano scale, more surface area. Sometimes you might be sir, the big one, no. The same thing when you convert into small like particles like this, what happened? If you collect the surface area of all these particles, it will be more than the surface area of this ball. Is that clear? If imagine this is a football. If you take the surface area of the football and if you take the surface area of all these tiny particles and collect, that surface area will be higher than the surface area of the football. Is that clear? Therefore, some students, they don't understand. They tell us the large one, more surface area. The small one, you have to add the surface area of all the small particles. Then it will be more than the large one. Is that clear? Therefore, now you got what is surface area? More contacts, more collisions with the reactants. Easy contact. They can easily move, right? And the interior particles also available for the HCl to contact. Therefore, simultaneously, all the reactions happen in advance. But here what happened? Only the surface of the calcium carbonate react first. Because HCl cannot penetrate in. It takes long time for the HCl to penetrate in. But here they are exposed to the outside. Is that clear? Right. So that is how the surface area, because not just to memorize, I explain how that happens now. Right. Then because anyway we are doing there are some practicals for each factor that affect. Next one, third factor that will affect the rate of reaction. Third one, right? Concentration of reactants. Concentration of reactants. What is concentration? That means more molecules per volume, per unit volume. Concentration high means what? Example, 2 moles per cubic decimeter. In 1 liter, 2 moles. That means more particles. 2 times of Avogadro constant. If you take 1 mole per cubic decimeter, low concentration. Here, low concentration, 2 moles per cubic decimeter, high. Same volume, but more particles. 2 moles contain more particles than in 1 mole. Volume same. 2 mole means 2 into Avogadro constant. If you take maybe HCl or something, 2 moles per cubic decimeter HCl means what? 2 into Avogadro constant HCl molecules. Here 1 into Avogadro constant HCl molecule. That means what? More HCl molecules in 1 liter when the concentration is high. That means more molecules in a unit volume. That means what? More contacts. More molecules available to contact with the other reactant. So that is called concentration. When the concentration increase, also rate increase. When the temperature increase, rate increase. When the surface area increase, rate increase. So sometimes instead of concentration, if the gases are involved, we don't call it concentration. If the gases are involved, then we use the term pressure. Right. We use the term pressure. Right. The next one, last factor, the fourth factor that will affect these 4 factors. You have to remember these 4 factors. You have to remember for the exam. They can ask. Sometimes they will not ask directly the 4 factors affecting the rate. They can give the practical. They will give the experiment. They'll ask the effect of which factor can be tested here, can be demonstrated. The effect of which factor on the rate. There can be more than one factor affecting the rate. Example, photosynthesis. What matters? The rate of photosynthesis. Light matters, but they have not given that here. But actually the other countries they teach that also. Here they have only 4 factors affecting the rate, but current and light also will affect. Example, photosynthesis. When the intensity of light increase, rate of the photosynthesis goes up. Right. Fourth factor, right? Catalyst also will affect the rate of reaction. Catalyst also will affect the rate of catalyst. We are discussing separately one by anyway. All these 4 factors we are going to discuss in detail one by one. Right. So remember, if the reactants are gases, we don't use the term concentration. We use pressure. So if you write for gaseous reactants, pressure we use for the gaseous reactant. Gaseous, GASEOUS. Gaseous reactants we use the term pressure instead of concentration. Because example, hydrogen and nitrogen gas to make ammonia ammonia is used to make urea, fertilizer. Fertilizer, CONH2 twice. So this urea, therefore ammonia industry. What are these gases? Hydrogen also gas, nitrogen also gas, ammonia also gas. All three are gases. Products also gas, reactants also gas, like that. Then the main factor, the pressure. When the pressure increase, what happen? Then they will collide more frequently, because pressure means high pressure means low volume, right? Then if you want, you can write additional information, the current and light, or additional thing, you can put a star at right the bottom. Light and current also can affect the rate of some reactions, like photosynthesis right here. Light and current, intensity of light, light intensity and intensity and current. Heat means temperature. Yeah, current also can affect the rate of reaction. Affect the rate of reaction. Is that clear? Light intensity and current also can affect the rate of reaction. I'll give another best example. If you look at, okay, if you have some after the class check in your house, you have various medical syrups and the the cough syrup, or like the medicines. Even the iodine salt powdered, the iodized salt powder packet in your or most of the canned food. Even if you have coconut oil in a plastic bottle, if you have mineral water bottle, they tell what? Not to expose to direct sunlight and heat. Store in cool, dry place. Why? Store it away from direct sunlight. Why some medicines are stored in brown colored bottles? Why it is not in transparent? Even Panadol syrup that is in a brown bottle. Why brown? To prevent the exposure of this medicine into the light, because that is called photodegradation. Photo means light, degradation means break-in. Photodegradation reaction can occur. Due to light, that product will break down. Break down, or the medicine. That's why we have to protect some products from light also. Right? Even if you are ironing clothes, sometimes it get faded away if you are using hot iron, like very hot, high temperature. Therefore, light intensity, that is additional. Yeah, the grade 10 textbook, they have not given this additional information. Light intensity and current. Current means say electrochemistry. There's a separate lesson in grade 11 electrochemistry chapter 12. So electrolysis we have done in grade 9, right? Electrolysis, electroplating. So the current matters. If you write here electroplating, electrolysis, the amount of current pass matters here. How fast the reaction take, electrochemical reaction. Current means example electrochemistry or electrolysis, electroplating. Current matters. Electroplating, current matters. Intensity of light, example photosynthesis. Not only the other those four, but these also will affect, but they are not given in the textbook. Photosynthesis, photosynthesis, light. Photosynthesis is also a chemical reaction. You write the word equation, balance symbol equation for photosynthesis. So there the intensity of light matters. In the dark, no photosynthesis. Right. So those are the factors affecting the rate of reaction. Now, the experiments I will discuss next day. Experiments. Now each factor, there's an experiment. How to prove this? How to demonstrate the effect of temperature on the rate of reaction. So they have given some selected reactions, but I don't think they'll give beyond that. Only the given example they'll test in the exam. Now I will go to the grade 11 biology. Last 15 minutes at least. Page number 2 onward I'll discuss next. Number 5 I'll discuss next day. Look at your grade 11 now. Living tissues, right? So actually 11, the first chapter, living tissues, it consists of both plant tissues and animal tissues. That's why we call it living tissues. Living tissues, plants also live in plant tissues and animal tissues. Microorganisms, no tissues. Microorganisms, you can't talk about tissues, only cells. Right? Unicellular organisms, no tissues. First we are going to discuss about plant tissues and then the animal tissues. First we are going to discuss about plant tissues and then the animal tissues. I have already posted this theory tube also to your WhatsApp. I'll show you that also. This is the theory tube. Event issues. You can keep hard copy or printout ready by next week of this also. Since I will start this today at the beginning because some of you might have not got. Please raise hand. Though anyone of you have got the printout of this also. If you have a print at home, you can do it. But otherwise, it's not possible to take. Some students you have got it. No. Okay. Good. Well done. Right. Okay. Right. Very good. Okay. So then, living tissues. Actually, what is a tissue? You have done in grade 10. Cells combine to form what? Cells combine to form tissues. Tissues combine to form organs. Organs combine to form system. And all the systems combine to form the organism. Blood circulatory system, excretory system, digestive system. Organs means example heart, lungs, liver, organs. Liver is an organ. Once in the oral paper they ask MCQ, which of the following is an organ? They gave liver. The tissues. Now if you take unicellular organisms, bacteria, right, fungi, so you can't talk about tissues. Right. Then system and the organism. So grade 10 you have done chapter 6, unit 6, plant cell and animal cell. Plant cell and animal cell. Plant cell and animal cell. Plant cell and animal cell you have done in grade 10, unit 6. Now tissues you are doing in grade 11, chapter 1. Grade 11, unit 1 you are learning about tissues. Organs and systems you will be learning in grade 11, chapter 6. Grade 11, unit 6. Right. Organism you learn about again in grade 11, unit 15. Organization levels of the environment and stuff, right? Anyway. And in medicine also they learn human only, like not the other organisms. Anatomy of human body, human anatomy. Now let's see the definition of a tissue. To become a tissue, one cell is not enough. One cell is not enough to become a tissue. So group of cells, that is one keyword. And the other one is common origin. Example, after combining the sperm and the egg, you get the first form cell in the mother's womb, the zygote. This zygote keep on dividing, producing large number of cells. Some of these cells get specialized to form the heart. Some of these cells get specialized to form the lungs. Some of these cells get differentiated to form the brain. So this is like differentiation and specialization. So that's why they have a common origin. All the organs, the tissues, so this, even though it's a different tissue, they have a common origin. So the first form cell zygote, all these come from the zygote at the end. Even though you have, so one cell zygote is not visible even to our naked eye, but you have now more than, like, maybe the average birth weight was around 3.5 kilos, a baby. Now it's, maybe some of you are now more than 35 kilos, no? So imagine what has happened during this time. From your birth weight 3.5 kilos to 35, 40 kilos. Now what has happened to your body? Cells, number of cells now it's increased. You have more cells than before. So you become fat. You are growing. Therefore growth is increasing of the number of cells as well in multicellular organism. Then you have tissues also. In the tissue also the number of cells might increase. You should have that understanding. Okay. Now group of cells underlined with common origin. Now you can understand what is the meaning of common origin. With common origin. This is grade 11, no? This grade 11. I told you parallel to the grade 10 last few lessons, I will be doing the grade 11 work also. Otherwise, we will not be able to finish the syllabus because now they have not informed yet. You are starting the first term in government schools in April 18th. Then the problem is what? Previous batches, now usually you are supposed to start in January in grade 11. Now government and semi-government schools, 18th of April they are still, that means 4 months gone. So definitely it's not possible to keep the exam in December if they start unless they do unless they keep the schools in Saturday. So after 1:30 also, if they keep some so then only they can do the exam in December, otherwise not possible. So that they have not confirmed yet. Sometime it can be next year April also. It depends on the situation, but again, if there's a pandemic situation and if there's lockdown, then this will become worst. But anyway, your time is the most important thing, right? Even though the private schools, even though they are finishing the syllabus early, now what happened? They have to wait until May. Some of the private schools, they have finished the syllabus by December, but now what happened? They have forgotten. Now 4 months, nothing, right? What happened? 4 months or nearly 4 months. So until April, what they have to wait to face the oral exam, even though they finish the syllabus early. Then what happened? During those 4 months, if you are not touching any of the notes, then you will forget it completely. Right. Group of cells with common origin and modified to perform a particular task or function. Example: brain cells. Brain tissue or the nervous tissue perform the function of the brain or the nervous system. It's not going to perform the function of the heart. Therefore, you can't take the tissues from the heart and transplant in the brain. They are not compatible. You can't take the tissues from your heart. You can't take the tissues from your heart and you can't put that in the brain. It's not possible. Because heart, they all common origin, group of cells. But heart tissue, the cells are different from the nervous cell, neurons or nerve cells. And they are different from the muscle cells, the skeletal muscles, or neck or leg or arm. Those muscles are different from the heart muscles. Heart muscles are different from the nervous tissue, the brain tissues. Remember that. That means they are specialized. Until your death, muscles of the heart perform that function. They don't change the job. If they are going to change the job, only one instance they would change the job. Example: muscles of your lungs, contraction and relaxation, and ventilation of lungs. They contract and relax, the lungs are working. Otherwise, that's why you need ventilators and a lot of problems with COVID-19. The main system, okay, they can ask these type of questions in the oral paper even. To which system the COVID-19 or coronavirus will affect directly? Respiratory system. In the respiratory system also, to which organ? Lungs. But later it will affect to the other organs also. But some people, what happened? They get infected with COVID, but they die from the heart attack. So there can be a blood clot. Sometimes they will get nervous disorder, right? Neuron. No. Some of them, they have long-term side effect. They have got even Parkinson, some countries, right? Lungs. Well, I'll give one example. They will change the job only in one instance. If you get cancer cells in the lungs, what happened then? The normal cells overcome by the cancer cells. Cancer cells are unwanted. They are not going to do the job of the lungs or the function of the lungs. They do the job they want. Therefore, then the lungs are not functioning properly. Why? Cancer cells are not going to perform the function of the lungs. Or if you get the brain tumor, brain cancer, they are not going to do the function of the brain, nervous tissues or the brain tissues. They are this different function. Other than that, healthy organ, until your death, they will perform that special task or the function given. They are not going to change that job. Okay. So that is very important in your body, right? After your birth, heart, until your death, perform that function. So you understand the meaning of this definition of it. They have a common origin, group of cells. So what are the three words? So group of cells also highlight. In the exam, if you get what is known as a tissue, they will not check your grammar or active voice or passive voice or grammatical the sentence correct. They will check whether these three keywords are there. Group of cells there. If you don't include that word, no marks. Or with common origin, whether that one is there, number 2, and with a definite function or task. Perform a definite function or task. Is that clear? Right. Then I have given this summary is not given. Okay, that is the definition of the tissue, right? Then next one, plant tissues. Entire classification of the plant tissues I have given here. This is what we are going to discuss under the plant tissues. I think they have not given this in the textbook. They have not given this flow diagram in the textbook. But O-level paper, they can give part of this flow diagram and ask questions. O-level science paper or term test papers, they can give the part of this flow diagram and ask questions. Right? Remember that. So example, permanent, okay, plant tissues are divided into two types, permanent tissues and meristematic tissues. Okay, why it is called permanent? Permanent means they are already specialized to perform that definite function. They are not going to change the job. Meristematic tissues, they are still growing, dividing, or growing, or the dividing cells. They are not specialized for the organ set. Actually, they are responsible for the growth. Meristematic tissues, or in single we call it vibhajaka pataka. In permanent tissues means sthira pataka. So meristematic tissues of, we call it vibhajaka pataka in the single medium one, responsible for the growth of the plant. Responsible for the growth of the plant. For the growth. Plant also growing. Plant increase in height due to the meristematic tissues. Responsible for, if you only can mark that with a pencil, responsible for the growth. The stem grows wider. Plant grows tall because of the meristematic tissues. They are found mostly tip of the stem, tip of the leaves, and in the internodes. Responsible for the growth of the plant. Responsible for the growth of the plant. They are responsible for the growth of plant. Therefore, meristematic tissues are very, because first they should grow. After that only they can do, you can get, timber or anything, right? So meristematic tissues are divided. We are going to discuss meristematic tissues number one. After that I'll go to this one, permanent. So this is the entire summary. This summary is very important. When the exam is close, you can have a cross reference, or it's easy to study. When you have a flow diagram like this, you know the entire content of the plant tissues. Then no need to turn pages and pages. You can quickly refer this flow diagram and you can check whether you know these things or not, right? Meristematic tissues are divided into three types based on the location and its function. Shoot apex and root apex means tip of the stem, and tip of the root, we call it apical meristem. Complete this blank, apical meristem. What is that? Apical meristem. Apical meristematic, apical meristem. So they are found at the tip of the stem and tip of the root. They are responsible for increase growth of the roots as well as growth of the stem. I mean, the stem grows to, vertically up. I mean, it grows tall, or plant increase in height. Plant increases in height. Plant increases in height due to the action of apical meristem. But if you plug the apical meristem, what are the best example? Plug in tea buds. When you tea leaves, or when they plug the tea leaves, they plug the tip of the stem also. Then what happens? The plant won't grow tall. It grows laterally and like a bush, it won't grow tall. But if you remove the shoot apex, or the tip of the stem of, like sometimes you might have experienced this rural areas, coconut beetle, Polkurumina, they damage the tip of the stem of the coconut plant. Then the entire plant will die. Why? Coconut no branches, no coconut, no branches. The unbranched stem, you have done monocot and dicot differences. Therefore, if you remove the shoot apex of monocot, the entire plant will die. But if you remove the shoot apex of dicot, the entire plant won't die. Example, amberella, like cotamba, like laterally there are more lateral branches, right? Then next one, right? Second type, cambium. You are familiar with cambium? Where did you learn cambium? Cambium you learn in monocot and dicot differences. Cambium present in where? Cambium present in dicot, absent in monocot. Therefore, that's why the monocot, coconut palmyra, long cylindrical stem, no lateral growth. The stem won't grow, it will not grow wider. But if you check jack, the base is broader than the top because of cambium. Jack is a dicot, cambium is present, then it cut off cells both inwards and outwards, and the plant grows, the stem grows wide. So there we call it what? Lateral meristem, laterally. Now what happened? Most of us, now most of the people, what happened? If you take too much nutrients, so we got obesity. So you are not growing tall much, you get goes laterally. Right? Laterally. But plant not like that. you go laterally, like most of the people like that now. It's like laterally growing. So this plant also the same thing. Plant actually, that plant also can grow like, laterally like this, but the lateral growth of the stem, the base become broader than the top. It grows laterally. That is due to the action of cambium in the stem. Cambium in the stem. So that is called lateral meristem. So lateral meristem is responsible for increasing the diameter of the stem. Increasing the diameter of the stem. So intercalary meristem I have already given. So what are the three types of meristematic tissues? You have to remember this: apical meristem, lateral meristem. Don't need to put 1, 2, 3. I'm just highlighting. And intercalary meristem. One of the best example, bamboo. Unabata, unagas or something. So this is the internode between the grass. So there are internodes. You can check grass or creeping stem. So there are length of this internode increase. Length of these internodes are increasing due to the action of what? The length of internodes. So that increases, this length increases due to the action of intercalary meristem, or nodes of the stem also come under intercalary meristem. So therefore this increase. So this one, the bamboo internodes, length increases between the nodes. Between the nodes, the length increases. When the length between the nodes increase, plant also increase in height, right? Plant increases in height. Okay, so that is about meristematic tissues. The best thing is what? You should know the location. You should know the name of the meristematic tissue, location, and the function. That's what I have given at the bottom of this tube. Look at here, I have given that. Look at the table also, then it's easy. Parallel to the meristematic tissue, I have given you the three meristematic tissues: apical, lateral, and intermeristem or intercalary. So I have given the distribution of the location: shoot apex, tip of the stem; root apex, tip of the root, or axillary buds, so which you get branches; and the lateral meristem, the cambium. Cambium present in the stem as well as in the roots. Roots are growing because of the cambium, like laterally. And nodes of the stem, intercalary meristem. So that is distribution. Function, right, under apical meristem, right, increases the height of the plant due to the action of, that is the main function of apical meristem, increases the height of the plant. HEIGHT, height of the plant. Then lateral meristem, right, increases the diameter of the stem or breadth of the stem. Then intercalary meristem increases the length of the internodes. I told you bamboo, grass, between the nodes the gap increases because of intermeristem length. Here the diameter of the breadth of the stem grows wider. If you write within bracket in dicot, so this is applicable for the dicot. Monocot, no cambium. Please write here, cambium is present only in dicot. Please put a stem right at the bottom. Cambium, that is apical meristem. Cambium is present only in dicot. Cambium is present only in dicot, but not in monocot. Therefore, monocot, the stem, monocot stem like this is like say coconut. Even diameter of the stem, but if you take jack, dicot stem, the base is broader than the top. Because of the action of cambium. Base become broader than the top. Is that clear, everyone? Right. So therefore, coconut, palmyra, monocot, the stem even diameter from bottom to top, the same diameter of the stem. It will not grow wider, or the stem will not increase in size laterally. Right. So that is the summary of the meristematic tissues, and the characteristics of meristematic tissues I have given above this table. That one I'll discuss the next day. This part number 3 I'll discuss next day, the characteristics of meristematic tissues. Then that part is over. This diagram also represents meristematic tissues. Table, the location and the function of meristematic tissues. Number 3, the characteristics of meristematic tissues. I have given in the flow diagram also where does that exist in this entire plant classification of tissues. Right. Then this one I'll discuss next day, the number 3, the blanks, and next week also I'll do nearly 1 hour. Next week we can complete rate of reaction. The lesson is not that lengthy, very short. Next week I can complete that, right? And but anyway, your grade 10 term test you are getting only from the grade 10 work. So this part I'll complete most probably only 2 pages. We can complete this next week, only 2 pages, and I'll be doing both grade 10 as well as the grade 11 first chapter. I will continue the rest next week, right? And tomorrow morning, Sunday morning, the paper class, I have posted a reproduction about 40 MCQs from the reproduction lesson. I'll be discussing those MCQs tomorrow, and I'll post one more paper. Then you can keep the answers ready at least by next week. Beforehand, I'll send the other paper also tomorrow, right? Right. Okay, then stop for today. Have a good day and God bless you.